All right, well, thanks for joining us again today for the Python for Deep Learning workshop. So in class today, as Jesse was saying, we're gonna finish up what we started with yesterday, and then we'll go on to use these examples and the things that we learned yesterday for loading some example data into our framework. And if we get through the material, we will also do some modeling today, sort of. Here's the link to the repository. Let me just send that right on over. Here you go. Just drop that in the chat if you need that again. And remember that you can click on that blue Open in Colab button if you just want to go ahead and code in Google Colab. So today is going to be a little bit special because we are working with files later on. And so the way that you use that through Google Colab can be a little bit different. And we'll talk about that when we get to that point. But keep in mind, things would be a little bit different if you did it on your computer, but it will be very similar. Okay. Before we get started, let's just do a quick review. We'll do a little rapid fire round. So just drop your answers in the chat, or feel free to just unmute and just shout them out. Okay. Let's go. Okay. So question 1. Give me some examples of some basic data types available through Python. So an example is going to be an integer. Ooh, good. Good. Float, string, great. Int, yep, float, perfect. Ooh, some people were listening yesterday. Good, good. All right, number 2, name a data structure in Python that we talked about yesterday. Yes, list. Dictionary. Ooh, on the ball, lists and dictionaries. Yes. Tuple. Ooh, on the ball, tuples and sets. Very good. All right, question 3. When we're creating lists, what symbol indicates that we're creating a list? Or what set of symbols? Perfect, good. Square brackets. When we're creating dictionaries, what symbol indicates that we're creating dictionaries? Oh, very good. Man, you guys are on the rapid fire this morning. All right, a little bit of a harder question. Name a pitfall that we talked about yesterday. So when you're coding along, what kind of weird mistakes can you make that kind of introduce errors that you may not have been expecting? Yeah, good. Copy, paste, spacing. Great answers. Ooh, interesting. Yeah. Great answers. Okay, another question. So let's say that we want to conditionally execute statements based on some condition. If they are mutually exclusive, what control structures can we use to direct the code to execute one statement versus another? Ooh, great. That's right. If else. Good. If else, or if else if, or else. Good, good. Yeah, we picked up some things yesterday. All right. What are some different ways of iteration that we talked about yesterday? Good. For loops. Yes. For loops. Great. Yes. And list comprehensions. Very nice. And there's also a possibility for a while loop. Ooh, great job. Man, you guys got an A on that little quiz. You can tell that you guys are academic people. Getting A's all throughout things. All right, perfect. Well, I'm very excited to see that you guys have grasped onto those concepts because they are forming the foundation of what we're going to do today. You'll see that a lot of just basic Python can cover so much of the work that we can do with deep learning. Okay, so let's go ahead and start where we left off yesterday. I think we ended where we were talking about, we just had come out of the breakout rooms where we were trying to get a little bit of experience with for loops and list comprehension. So let's start with that. And I'm going to go ahead and share my screen. And we'll go over once more about how we can open things up using Google Colab. And recall also that for all of the notebooks that we have here, there's also a solutions notebook. If you happen to get a little bit behind or maybe just want to take a look at some of the solutions, feel free to click on those and open those. But the best way to take this workshop is to actually use the in-class notebooks, which do not have the solutions at the end, and code along with me. Okay, so the way that we can open this through Google Colab, we're just gonna click on this blue Opening Colab badge. Wonderful. And then let's go ahead and click on Python Basics. And that's the notebook that we were in yesterday. So let's click on that one to open it. And here we are back again. Wonderful. Let's see, I think I also have this open. Good, good, good. All right, so where were we? Let's see, we were in iterations. We were talking about list comprehension. So you can scroll on down to the list comprehension check section. Something cool that I did want to tell you about with Google Drive, or sorry, Google Colab, is this little button here. I love this because it kind of tells you exactly the layout in terms of the headings. So these are all headings. It kind of tells you what we're going to be doing today. So if you ever want to get a really good overview of where we're going, where we are, and what we're doing, just click on this little, it's not a hamburger, but it's like a menu, and it shows the table of contents based on the headings that we created. Okay? Okay, great. So I'm just going to close that back for now. We'll look at that again in our next notebook. Okay, so let's start with list comprehensions. And can someone just quickly remind me, how can I execute this again? How can I execute that cell? All right, great. Good, good. I can shift enter it, and it tells me, hey, execute stuff. Are you sure about that? Yes, we are sure. This here is starting my kernel. There we go. Okay, and so here, let's make this a little bit bigger because actually even I can barely see this. All right, we're gonna make it just a little bit bigger. All right, there we go. So here we can see the execution. Again, we are just creating a string that you guys told me about. We're storing it into this variable name called sentence. Oh, we talked about this part. So split. This is a method for strings. So this is our string that we have. Split is a method. The default behavior is to split the pieces based on the spaces. Okay, so now whenever we split that, we get back a list. So we've just decided to call that sent list, and we can see that we are just outputting sent list here. And so this is what it looks like. It's a list of 3. Wonderful. Okay. Now let's see. We started with these in-class exercises. Let's just open up that cell bit. Here we do something similar. So you guys were working on something just a little bit harder than our example in class, where we were doing a split again on this big long string. But now we were splitting on these periods here. So again, we split based on the periods. You can see that we passed an argument to our method that we're applying to our particular data type or our particular class. And then let's see how this one goes. We can also click this arrow to run this. So again, we have a list with 3 elements. You can see that there's 3 strings. Okay, interesting. What is this? This is an empty string. Keep that in mind, that comes up. Sometimes you want to check and make sure that that is there. So there is something after this and it's nothing. So this is an empty string. Okay, so we have 4 elements. I just said 3, but there's 4. Okay, if we ever want to check that, what's that method that we talked about yesterday? If we want to know the length of something, just remind me. I remember. Ooh, very good. So Lynn will tell me how long this is. Our list. Okay, and there we can see 4. Again, just remember, if you're outputting something, it will only output the last thing that you output. So now we don't see par list anymore. If we wanted to see it, we would need to print that. Again, these are just things to keep in mind while you're coding. Okay, so just a quick review. Okay, so based on the in-class exercise, would anyone like to either drop in the chat or direct me to somewhere in our breakout room document where they'd like to discuss these answers? So the first question was, how can we create a list containing each element of the list? So basically outputting each of these things using a list comprehension. Would anyone like to drop that in the chat or unmute and discuss from the breakout room document? Just let me know. Let's see. I'm feeling a little shy. I'm just going to take a look right quick and see if anyone has answers here. Oh, breakout room 7. Looks like we have some answers. So we said sent or sent in par list. I'm going to do the unbelievable. Okay, we're going to copy and paste it. Good. Thanks, Marcus. The sent, yep, perfect. Let's copy that one. I'm going to copy that one over. All right. So sent or sent in par list. Let's see how this goes. Lists. Okay, so we're going to print out each of these things. Okay, good. So this is looking like it printed all of the elements that we wanted. Good. Nice job. Can someone quickly just remind me what the pieces of this are is? What the pieces are again? So what is this for sent in par list part? Like what is sent and what is par list? What are those things doing? Beautiful. For each item in par list. Good. So this is the actual thing that contains our data. So this is the list. And then this is just like a dummy name that we give to each of these elements. What does this part do? It's the thing that we want what? Yes, good. That's the thing that we want in the list. And I just wanted to quickly say, sorry if you hear me snorting a little bit. I'm just basically trying to breathe during allergy season. So sorry about that. Okay, so great answer. That's the thing that we want in the list. All right, great. So let's see number 2, a list which contains strings which only have uppercase letters. So we expect, okay, this one only has uppercase letters. This one has mixed case, and so does this one. Okay, so let's see. I'm just going to go and see what you guys have answers here. Let's try this one out. Sent% in par list if sent dot is upper equals true. All right, let's try that one out. It's making sense to me. Looks like you guys did a little bit better than I did yesterday because I just had just plain upper there, uppercasing something as a condition. It doesn't make sense. So let's see, let's just parse this mentally. So it's kind of the same thing that we had before. So we're going to output everything in the par list, but only if that element is uppercase. So if all of the letters in that are uppercase, and if that's true. Okay, let's see how that one goes. Good. That's exactly what that returns. Nice job. And see, it's interesting that you could, it depends what you want to do here. So if you were to save this in par list, so save it back to par list, you would actually have a different set of values in par list. Okay. Let's see, and this returns a new object. So it's not updating, but it's just creating something new. Okay, let's see, bonus, create a list which contains all the strings. So we're trying to not select, but we're trying to do an operation on this, okay? But lowercase strings which have only uppercase letters. So let's see what we expect here. We expect to have this one. We expect to have all of these in the answer, but we expect this one to be returned lowercase. Go take a look at some of the answers that we got. Let me just copy this one. Let's see. Okay. So let's take a moment here. Okay. So we have this for sent in par list. So we know that we're going to try to return the element. every time. But what are we returning? We're returning sent.lower, so lowercase, if that element is all uppercase. Otherwise, we're returning just the value. So let's see that here. Okay, so we got exactly what we wanted, just what we expected. Perfect. And I think someone yesterday asked what happens if we take out this piece. So do you really need this other piece here? We can just quickly take a look at that. Okay, so we just took out that piece. So this throws an error. It really likes to see this ternary like operator because I believe it's not sure what, like what else. So if it's not this condition, then what else should it do? We might think in our minds that it should do nothing, but it needs, in its own mind, it wants to know for sure. So what do we say? Else. Okay, good, good. All right, wonderful. For the super bonus, I didn't see any answers there. I called that super bonus, that's funny. All right, so there's another method called find, where it can find substrings in a string. If the string is not found, then it returns -1. Create a list which returns only sentences where the string dog is found. Interesting. Note that since there are varying letter cases here, it might be helpful to lowercase these letters. Let's think about that. So we're thinking that we're going to probably have something like this structure because we're actually doing something that is filtering-ish. So we're only trying to return a subset. And we're trying to find if dog is in these strings at all. Okay, so we would expect to get this one back, and not this one. Okay, so let's think about that. What might that look like? So we know we're going to have 4 cents in par list somewhere. All right, and we're going to return. We're trying to return the element. So we don't want to do anything to it. We just want to return the actual element. But we want to return it based on some condition. If we said, if that element got find, and we wanted to find dog in there, is found, meaning that it does not return -1. Okay, let's see how this goes. Ooh, interesting. It returns nothing. Empty list. Interesting. So why is that? Okay, someone has a great answer there. Great answer is that we need to lowercase this. So actually, so you can see this one here, but this is not our actual values. So this is actually our list. This string here actually never occurs here. It has a capital D or all capital letters. So this never occurs. So someone very astutely said, if we lowercase all of these, then we would be able to find a match potentially. Okay. So if we wanted to find any instance of dog, regardless of case, we could just lowercase any of these elements before passing it into find, and then give that a try. Okay, so this is lower, it lowercases the sent, and then we try to again find dog in there. Okay, so let's see. All right, great. And note that this does not actually change the values of the string. It actually just, in its mind, it says, okay, this element, I'm going to lower it and see if I can find it. But then it returns the actual element. Okay, so here we go. And a nice super bonus. Okay, good. So you also have some additional exercises. I think some of you might have already gone through those. But now we're going to talk about the last big chunk and power of Python and programming languages, which are functions. Okay. So secretly, if you recall yesterday, we've already done some very like functiony things. And we've already actually used a number of functions. So we talked about, we used the print function, right? So we gave the name of the function. We had these parentheses, which indicate that we're actually doing an operation. And within there, so within the parentheses, we could place an argument, okay, right? So with print, we put a string that we wanted to print. With len, we passed in something that we wanted to find the length of. And we can do that same thing, except for customize the behavior of those functions. All right, so what does that mean? So let's just look again at one more time, and let's look at the print function. So we have print, the name of the function. If I could just type that correctly. I'm just going to move this up a little bit so we can see things. So print, built-in function or method, wonderful. And then you can see here, this is why I just really love Google Colab. It actually tells you the things that you can pass in. So these are the arguments. Some of them have default values. So the default values you can see when you see this equal sign equals something, this equal sign equals something, that basically just means those are just default. If you passed in nothing for that, it would take these default values. But you also see some here that do not have those equal signs. Those are required inputs. Okay, so it's saying, hey, you're trying to tell me to print something, what is that thing? You need to tell me what it is. Okay, so that's what we're going to be printing. All right, so let's take a look at that. So we can print something like hello world, as we've seen before. And that is precisely what happens. Interesting. So now let's extend this. Okay, so this is using a function, but we sometimes need to write and define our own functions, which will do operations that we want. So earlier in the class yesterday, we talked about this conditional statement that would return whether something is uppercase, lowercase, or mixed case. Okay, so let's see. What if we wanted to instead turn that into a function? So think about this. Before, I don't have it here. Let me just open this right quick so we can look at it. Just a moment. Oh, thank you. It actually opened it up on GitHub. Bless it, bless it, bless it. All right, let's take a look. Sorry, we're gonna make it there. Don't look if it's making you a little bit nauseous. Just close your eyeballs for just a moment. We're gonna get there. Here. Okay. I made it almost there. Sorry, we're almost there. Here. Okay. Here. Okay. So this is the function, or no, it's not. These are a set of conditional statements that we use to understand whether this thing word was uppercase, lowercase, or not. Okay, so I want you to think. Let's say we have 10 words, or like we use the split method thing. We had a bunch of different pieces or a bunch of different words. If we had a bunch of those, how would we call or use this to determine whether each and every one of them was uppercase, lowercase, or not? Mixed case. It's a good question, huh? For me. Oh, Pedro is right here with the answer. That is great. Yes. So the best way to, so good. The best way to do this is to use a function and have this, so the thing that you're trying to test, passed in as an argument. Now, without the functions, let's think about how we would have done this. We might have been copying and pasting that thing that is results in error-prone behavior. For each and every element, we would have had to explicitly write it and then write this with that new thing, like that new element there. Lots of copying and pasting. Terrible. And then let's say maybe we wanted to extend this. We said that we can have other else if. Maybe we wanted to add another piece in there. All right, then for that huge notebook that is pretty much contains only copied and pasted a bunch of times, for all those times that we copied and pasted it, now we need to add that other line for all of those times. So functions, they can save the day. They help you with maintainability and reproducibility. Okay, so let's take a look at what that looks like. Okay, so we need to define the function. How can we do that? So def, because we're going to define, and then we need to give it a name. So print has a name, we're going to give this function, which is determining which case the element is. We're just going to call that which case. Okay, so now that we've given it a name, we need to define the arguments that it will take. Interesting. So what arguments will it take? Yes. So Pedro said before that it needs to take that string or that input or whatever to be able to operate on, right? So we're just going to call that for now fun input, function input, but it's also fun. And again, since we're defining something, we're going to use this colon to indicate that the block of indented text which comes after is relevant for this specific function. Okay, so now we can just put in the code that we had before. So we're just going to retype this because I don't have it up there already. So I'll just add it here. Okay. All right. Okay. Let's see. So if, okay, now we need to use the name of the dummy variable that we are trying to test. So if fun input is upper, again, colon, an indent, because this is specific to this condition, then we're going to print, what can we print? Fun input, and then we're just gonna print dash all uppercase. So this is allowing us a little bit of flexibility. I'm not sure if we saw this yesterday, but you can put in a number of things to the print statement, which will allow you to print them together with that separator that we just saw as separating these pieces. So we'll have fun input, space, dash all uppercase. Okay, so let's take care of the rest of the conditions. All right, elif fun input dot is lower, and we said we wanted to print fun input all lowercase, and then we wanted our last condition. Almost put a condition there. We just need the else because it's all mutually exclusive. Print fun input, and then we're just going to do next. Okay. So I'm going to do something very explicit right now, and I'm going to also have it return something. Okay. So that basically means that whatever is calling this will get a value back into the code. Okay. So for here, we're just putting these to the screen. You can also return values. Okay. So what we're going to turn here is just none. So if we were to not put that there, it would have also returned none, but this is just very explicit on what we're returning. Okay. So now let's give this a try. So we're executing this. Oh, let's see. Okay. And now we're going to try to call this function. All right, well, how do we do that? Well, actually, we do it very similarly in the same way that we call the rest of the functions, right? We just call its name, what we want it to do. So which case? And then we're going to pass in the argument, just like we passed in the argument here. Here, it's going to be dog, maybe, or whatever you want to pass in. Test case. All right, let's see how that goes. Oh, it seems to work. Okay, let's see. Let's try the uppercase. And then mixed case. Oh, so something cool about this is that you can actually output the actual input as well when you're printing. This can help you do a little bit of debugging, which can be really nice. Okay, so that's cool and all, and it is cool and all. But sometimes you want to return something in particular. So this is nice because it prints something to the screen, which we can see as people. But what if you needed your code to do something following and based on the case? How could we do that? Or what if we use this to actually change and return the change input? Let's see what that would look like. So now we're going to write a function, which is going to be switch case. Okay. And what it's going to do is it's going to be very similar to what we had before, but it's just going to switch the case of what's going on. So basically, if we have something that's all uppercase, it's going to make it lower and return that. And if it's all lowercase, it's going to make it all upper and return that. Otherwise, it's going to swap the case of the letters. So we're also going to introduce a new function for strings. Okay, so let's see what that looks like. So again, we're defining something, and we're going to call it switch case. Okay, and then we need to say the arguments that we're operating on. So we're going to just do fun input again. Keep in mind also that you don't actually have to pass, or you don't have to have any arguments passed in. It can just be something that operates, period, okay, regardless of the input. So now we can write our if statements. So I'm going to write it here, but you guys take a second and try to do it on your own. So try to think through what you should write here. So again, if it's upper, if the input is upper, you want to switch it to be lower. If it is lower, you want to switch it to be upper. Otherwise, you want to swap the case. Okay, so the function that does that is called swap case. The method that does that is called swap case. So I am going to just stop sharing my screen a little bit while I type this in, and then you guys give it a try and think about it. And I'll start sharing it again when about maybe a minute has passed. All right, and we are back. So let's see what that looks like. All right, so it's very similar to what we had before because we have the same kind of conditions, right? So we have if it's upper, if it's lower, or otherwise. But now for all of the conditions, we use that input and then we call a method on it to change its behavior. And again, look at this. So you don't actually need to pass anything in sometimes. Depends. So we're going to talk about why this is different a little bit for regular functions. We'll get there. But then after we perform this, we will update the original value. Okay. So keep in mind that you don't actually have to do it like this. We could have just defined some other variable name here and it would have been immaterial. But this is a way that you can work with this. Okay. So let's see the behavior of this, right? Is anyone feeling confident that this is going to work? We can give it a try. All right, so let's see. Switch case. Dog. Looks like it didn't do anything. That's interesting. Maybe it's because I didn't save it into a... Oh, man, Danny, you beat me to it. Nice job. Nice job. So I was going to say maybe it's because I didn't return this to something and take a look at it. It would have been immaterial. So as Danny said, I actually returned none. As we said before, it implicitly, when we return something, it is none. But we can take a look at that. I think this should work. We can take the type of res. So we returned a none type, which is none, unless we actually return something. So someone said, she said, must return fun input. Okay. Oh, be careful there. All right. And so we're going to return fun input. Execute that one again. And and we'll just take a look at that. So now you see the behavior of returning something, which is so nice because it returns something which you can use later. Isn't that cool? So let's see, let's run that. Oh my goodness, and it seems to be working. Oh, and I think maybe I didn't tell you about this. So again, this is what swap case looks like. It'll just swap the case of whatever your input is. So let's take a look at that scenario. So let's try that. We can see the reverse there. And then let's take a look at all uppercase and we can see the behavior. So that is pretty exciting. I remember when I started coding, I loved functions so much because they're so cool. So now this is really why, okay, so I just keep saying how much I love this, but let's see what this looks like with list comprehensions. So how could this help us when we're doing list comprehensions? So something that's interesting about for loops is there like one potential advantage is they're able to perform like more expansive like conditioning and behavior. But if instead you were to choose to make all of that functionality into a function, you could replicate that same behavior within a list comprehension. Let's see what that looks like. So let's say that we're on sent list again, and let me just make sure I know what sent list looks like. All right, oh, whoops. Sent list is not defined. No, it is not. All we have is sent list. Okay, so this is dogs are cute. Okay, good. And now let's try to switch case on all of these. Let's see. So we said we're doing a list comprehension. We're doing for L in sent list, and I'm just using L as my dummy term. What are we trying to do with this? We're trying to return the switched case of the element. So we're trying to call a function on this element, and the output of that is what we want to return. So let's see what that would look like. Well, we said we wanted to call the function, switched case. We wanted to call it on the element, okay, for all the elements in sent list. Let's see what this looks like. So this was what we had before. So lowercase dog, big R, R cute. Let's see what this returns. That's looking right. Let's just make sure of that. So we can instead just start by printing sent list. So the original. And then we can see the behavior after we've called this list comprehension with this lesson function that we've written. So now we should see it looks like things are working correctly. Uppercase, lowercase, and switched case. And I see someone has raised their hand. Why do we need a bracket? Which bracket? This one? Oh, I remember when I started coding, I used to see this all the time, and I was like, oh, but this is right. It's because it actually doesn't know. So what we're trying to do is create a list here. And so the reason that we need a bracket is because brackets are used to create lists. So this just means you're gonna do all this stuff, and then the data type or the data structure that should be returned is a list. Now, I think if you were to take out this, the brackets, you could turn this into a ternary operator, but that's something that I just have to look at in a second. I am obsessed with this show. I am obsessed with that statement. Show said, can we just use L.swapCase instead of calling the function? Yeah, let's see. Oh my gosh. Show, you are the coolest. I love it. I love it. So this is something that we could have done instead if we didn't want to call this function. But this does demonstrate that if you do want to call it, how one can do it. So maybe this is a little bit more expansive. Maybe there's something more expansive that you wanted to do here. Maybe you just wanted to capitalize the first letter. Maybe you wanted to snake case it Maybe you wanted to strip out periods. Maybe you wanted to do all these different kinds of things. You would have needed a function if you wanted to, particularly if you wanted to do all those things together. But that is great, great, blessed insight. Nice job. So I'm just going to write this here just in case you want to reference it. Okay, so there we go. And now we're going to have another in-class exercise. Okay, so what are we going to do in this exercise? Where you guys are going to go into breakout rooms and work together. Okay, so what's the objective here? What are we doing? Let's see. So we did paragraph.split, and that's parlous. So I'll just run this here so you can look at it. You can see that actually we have some white space here that we don't love. Maybe we don't want that. And we also have this unfortunate string here that we also don't want, right? Maybe we also want to have the periods at the end of these sentences. Okay, maybe we want that, right? So let's see. We can write a function which will do both of those things at the same time. And you can use the strip method to remove white space from both sides of strings. So if you were to call L.strip, it's going to snatch out this and this. And if there was white space on the other side, it'd do the same. And you can concatenate strings using this plus sign. So now if you had some element like this, and you wanted to just tack on a period at the end, you could just use the plus sign and then tack on a string period, and you'll get this, okay? So your objective is to create a function, just like we had with switch case, which is going to accept the string, strips this white space off, and then add a period at the end of this, at the end of each string, and then return the modified string like we did with switch case. Lastly, you're going to use a list comprehension to apply all of that to parlist. Okay? So let's have a breakout room for maybe 8 or so minutes. And I'll stop sharing my screen. If you need us for something, just I think there's a function in the breakout rooms which will allow you to call us and try to put your results directly in that breakout room document so that we can discuss when you come back. It's easiest if someone just goes ahead and shares their screen, and then everyone else kind of like talks about how to type it in or what should be done. But in the chat, or you can feel free to talk us through your results in the breakout room or what. Anybody interested? Great. Ooh, okay, we have an answer. All right, let's take a look. All right, here, let me, oh, I forgot to share my screen, folks. Share that. All right, let's get that here. All right, someone says, I'm just going to rep, okay, modify string in L. Okay, so I'm just going to copy from, let's see, someone has show. I think I see yours here. Let's try that. All right, so let's see. We're going to define, we're going to call it modify string, like that name. Just going to call the dummy element L, colon, because we need to define what's going to happen, tab, because we need to say that these things will happen if we're in this function. We're going to have another variable sent, and we're going to store into that the element, the stripped version. And then we're going to take that same variable and update it with sent plus period. Oh, and you wanted to do this one. Okay, good. And then we're going to return sent. Okay, that's looking, that makes sense to me. All right, and then someone said, and then if we wanted to test this, then how would I test this? So for sure, I would call the name of the function a modified string. Oh, I love this. By the way, we will talk about doc strings, but you see how this pops up because we defined this function. If we included doc strings, it would provide all of the information that you do in a doc string, including what the different input arguments are, as well as what they are defaulted to be and what it means. So it's either here or there. But it's just something nice to always have your documentation for these reasons here. Okay, so let's see. Actually, I'm going to test this actually on par list. So I'm going to try and I'm going to do par list. Guys, how do I get a specific element out of a list again? How do I do that? Good. And I'm going to use, so what is the lowest, not the lowest, but what is the index of the first element in that list? So what is the index? Good. You guys are just evolved. Crazy. All right, let's see. Okay, so things are looking good. So we didn't get a strip part because there's nothing to strip, but we got the period at the end. Let's see what that looks like for this next one. Okay, so there was a space here. All right, it's looking good. Stripped out that unwanted space, added a period at the end. Great. All right, the list comprehension. Oops. List comprehension, someone also said, so we said we're trying to make a list, right? So we're going to modify string. And they said pass in the dummy value L because we're doing for L in par list. Let's see what this looks like. Okay, that's looking right. So this one is exactly the same as the original with a period, stripped with a period, stripped with a period. This is an empty string, but it now has a period, which is perhaps unwanted. So something that's interesting sometimes is this kind of blank situation. We kind of want to snatch that one out sometimes. So we can also put a condition in here. So we could do, so we might want to filter out the blank one. And what we can do here is just add a filtering statement. So maybe if L is not that. So this is basically, again, looking at all the elements in the par list. And we're doing this operation only on the ones where it's not this thing. All right. Let's see. L not equal to. That one is working okay. I want to say that it is more Pythonic to do is not, but don't quote me on that one. Usually when you are comparing to things that are empty or would evaluate to false, we like to use the is not. But don't quote me on that one. We'll have to look into that one again. But it could be that. Okay. All right. Oh, all right. So I think that is the end of this notebook. So we have learned a lot in the last 2 days. We have learned all about the data types that you guys talked about earlier in the list, iteration, for, conditional execution, list comprehensions, functions. So when you come back for this break, so we're going to take a quick 5-minute break until 11, I guess 11, take a wish. When you come back, we're going to apply some of this for processing your data. And we're going to have a little moment where you're going to see what it's like to use a model, sort of. And you'll see that when you come back. So when you get back, again, at 11:11, we will go into the 4 notebook, and I'll see you there. All right, everyone. I think we are on our way back. Feel free to make a wish. 11:11.
Reminder to unpause the recording if we did that over the break. I'm not sure if you did or not, but
I'll need a reminder to pause the recording during breaks.
okay.
All right, making our way on back. Making our way back. All right, good. So I am very excited about this notebook today. As you can tell, I'm kind of an excited person. I'm very excited when it comes to data science and coding and Python. I love it all. So I just say that a bunch, but believe me, I'm very pumped. All right, so let's see. So now we are going to go into using the tools that we have just learned in the last moments here, as well as yesterday, to actually work with some data that may be in a similar form to what you all will have. So let me go ahead and share my screen. And we're just going to pop right on back in the repo real quick and take a look at a scenario of what you also might have. So here we have our repo, obviously. Normally, we don't tend to save data in the repo, but because we're working on Google Colab today, because the text is a little bit small, we just went ahead and put that in the repo so you would have direct access to it. So those files are stored here in workshop files. Let me drop this link back into the chat. Or would someone mind doing that? Just drop that link in the chat for me so everyone can be able to access the repo and look along with me. All right, so workshop files. So we're going to click on that. Let's just take a look. All right. So here we have a bunch of text files. These text files could be literally anything. You can take a look at them. I randomly generated this text. So if it says something untoward, let me know and I will just take it out. I didn't actually read it, so that probably wasn't the best thing for me to have done. So if something untoward, just let me know and I will take it out and replace it with something else. But these are the text files and maybe you stored them with some type of ID that identifies something. Okay, so these are just some identifiers and I've just made them integers because there's no telling what could be in your data. So these are all the text files that we'll be working with. And in our scenario, they're going to be articles that people have written. We might also have something that says something about the authors. So a CSV file, for example, and let's just take a look at that right quick. So this is something you might have. Maybe you're doing research on newspaper articles. Maybe you've interviewed people. Maybe you're working with legal data. Maybe you have some kind of data frame which contains all of the information that you're either trying to do inference on or predict or model. And so this is what we have here. What we have is a set of authors. So we have them organized by their first and their last name. We have their age, how long they've been journalists. And we also have their college major, as well as the article IDs. So this format is a little bit, just a touch contrived to what you probably would normally have in terms of data setup. What you would probably have is the reverse, or a set of 3 tables, 2 tables where you'd have all the information about the authors with their own identifier. And then you'd have the information about all the text related back to the identifiers of the authors. But just for shortness, and so we'd be able to do an example today, we have all the articles here. So their ID corresponds directly to what the title or the file name of the text is. So again, here are the writers, here's their specific article, and here are their college majors. Okay. All right. So again, those identifiers in this CSV file are going to correspond directly to the text that we have here. So hopefully this is good. All right, so this is the text. So they have some concerning development that they could get out their mind. This is the article that they wrote. And if we wanted to know who wrote this and we wanted to know things about them, we would go back in our table and look at this specific identifier and we can find out the author's information. So that's how that is set up. So now let's look at our notebook for today. Now that we know a little bit of what our data looks like, let's look at our notebook for today. And that's going to be this 4 notebook. So this 4DS with Python. Now that we know that, let's open that up in Colab. So we're going to click our blue badge again. And we're going to scroll right on down to this Python, this 4 notebook. By the way, So it may seem that we learned like, some basic things today that are not these expansive data science things. But if you take a look at this notebook, this is how I generated some of these demo texts. It uses all the things that we talked about. So what we talked about are very, very useful tools to be able to do a lot in the majority of things that you need to do with Python. All right, so that being said, let's jump into this 4DS with Python notebook. Yes, here we go. All right, so one last thing I wanted to say before we really get into this notebook is that here you're going to see a lot of examples, but the way that they're implemented, as we saw before, there's lots of different ways that you can implement this. We are just looking at one way. And so something great for you to do after this workshop is to go and see if you can implement this another way. See if there are better packages, or see if there are better methods or better arguments that you can use to accomplish this more in a more expedited fashion. So there's lots of ways. This is just one way. Okay. So I said that was the last thing, but there's actually one more thing. And that is, as I was saying, we're on Google Colab. So normally you might be doing this on your own computer or maybe on Acre. And because of that, we're doing a little bit of a workaround in terms of loading the data files. If you were going to try to do this in a normal way with Google Colab, you would want to mount this in your Google Drive and interact with the files there in that way. But here we're just going to read them directly from our GitHub, and you'll see what I'm talking about there. So let's just take a quick look. I am so obsessed with this table of contents. So we're going to talk about our example scenario. We're going to figure out how we're going to access the data. We're going to take a quick look, a little bit of EDA, because it's always nice to make sure what you read it is what you expected. And then we're going to solve the problems from our example scenario. Okay. So looking at this very beginning part, this is something you haven't seen yet. These are importing packages. So if you're familiar with R, you might know about library. Other languages also use packages that provide this pre-created set of functions that you can use to accomplish your work. So we're going to be importing Pandas, which is a tabular data analysis package in Python. We're going to be using NumPy for numerical analysis, and Seaborn is a really great plotting package. We're also going to use these helper file packages. So glob is so great. When you use this on your local computer, glob is what you'll want. It allows you to kind of look at all of the files in a particular directory or a number of directories. Request is a piece of our workaround today because we are going to be reading data directly from our repository, given its web address. Okay, so let's go ahead and execute that one. Okay, it's saying warning. This is source code from a GitHub repo. It's ours, so we're going to run that one. It's going to take a second just to get that in. There we go. And run this one. This is just a helper again, because we're doing a little bit of something different on Google Colab, but it will be very applicable to what you will do as well. Okay, so we're going to run that one, making sure that Colab is true. So as we said before, we have that data set, and maybe what we're interested in knowing is, did the journalist college major affect the sentiment of their articles that they've written? So maybe engineers write more terse or maybe happier articles, maybe they write maybe more negative articles, maybe the tone is just a little bit challenging as opposed to maybe what a humanities major might write or what a pre-law or pre-med might write. So the way that the person has decided to take their first crack at this is to first get the sentiments from these different articles using our deep learning techniques that we'll learn about next week. And then we're just gonna count the sentiments based on, the articles for each group. So if for all the people who had humanities majors in college, are their articles majoritively positive or negative? What about pre-law? What about business? So that's what we're going to try and do today. So the first thing we need to do is to read in the data so that we can process it, right? And so if you were on your local computer, you would use glob. So if you go to clone this repository on your local computer, you would run this cell. So we can still run the cell. This is why we have that collab Boolean, because it is, oh yes, true up here. So, but it's not true here. Anyway, so we'll run this. This is going to do nothing because collab is true. So instead, we're going to take this approach here. So I have went ahead and listed all the files for you. So these are all the files. Note that they're integers because these are just values. And then we are going to be loading this. This is going to look really familiar. This is our repo, and this is where our files are. So we have the file base, like you would have the directory on your computer. And we have the actual files, which you would get from Blob. How can we put these together to make a full file name? Let's think about that. It seems like if we were to iterate through all the files in this file list, so all these numbers, if we were to turn that into a string and then concatenate that with this string of this and .txt, that would give us the full file name. Wonder how we could do that. That might be a good job for does anybody have any thoughts about what might be a good thing that we've learned about that could help us to go through this list and do an operation on it to return another list?
I'm trying to comprehend what you're asking.
You do. Great, you guys. List comprehension. So we're going to take a minute and you try to do this on your own. So I'm just going to, you're trying to do it on your own. Again, keeping in mind that you can convert these values to strings using str. So it'll be string and you'll pass in the W value. And then when you want to concatenate, as we saw in our previous example, we'll use this plus. Okay. So take a minute and try and do that on your own. And then you can, well, just take a minute on your own. Oh, and where you're putting that is right here. So you're trying to make the file names and you can enter your own code right there. All right, let's see. Does anyone have any thoughts? You can either tell me directly what to type or maybe just drop it in the chat. And always feel free to unmute. Always feel free to put it in the chat, whichever you prefer. Thoughts, feelings. All right. All right, we have a valiant effort here. Let's see. I'm going to try it out. Actually, I'm going to copy and paste right from this. Let's see. Actually, no, I'll just type it. So we have, all right, we're making a list comprehension. So we have the list part, and then we're going to use this file base. All right, file base. Before we get there, let's talk about what we're going through. For ID in files list. Okay. So that's going to give us all these different IDs back. All right. And then what are we returning? We want all of them. We want file base. So we want that little base part. And we want to add that to the string version of each little element. And then we want to add that. Okay. So let's leave it there. All right. So let's give this a try. All right, that is looking very, very, very good. Very good. Nice job. The only piece that we might want to, beautiful. The only thing we might want to add at the end is this actual file ending. So we're going to add a string, which is going to be .txt. Let's try it again. Bless it. All right, there we go. All right, good. So now file names contains the list of all the files that we want to load. Interesting. So now we need to read the files. Interesting. So there are ways that you can do this. So this is one way again, but there are lots of ways. And so what we can do is, okay, we can use the request package and use request.get to get the content from whatever file we put in. And then we can use a dot text to get the text out of that structure that's returned. Let's see. So let's do this one together. So we have a list of these things, and we want to call this function on every single one of the elements in this list. Again, what is a way that we might be able to do that? Thoughts, feelings. List comprehension, exactly. And so I hope you're seeing now how ubiquitous and how helpful this concept is that we've learned in Python. So let's see how we might do that. So we want to get all the file contents, and we're going to do a list comprehension, and we're going to do it. What do we call that thing up there? File names. All right, so we want for each file in file name, so for fname in file names, what do we want to do? We want to use this thing here, request.get, all that good stuff. So we want to get requests.get. We want to call that or the file path URL here. And then one of the last modifier that we need is to be able to get the text out of that. Oh, nope, the text. So what we're going to do when we get this request.get fname is we're going to get the content, but what we specifically want is the text. Okay. So let's see how that goes. So let's run this one. All right. It seems like it's taken a moment. All right. So it seems to have done something. Now let's see how that went, maybe. So let's see. Let's just run the cell, print length of file contents list. And it's going to print the len of this thing that we just made. All right. And then something else is going to happen. And someone might have to explain this one to me. Actually, I might have to explain that one myself. So let's see. Let's run this just to see what's up. So the length. So we read 20. We read 20. Okay. So, all right. If we were to go back and count that, it might be 20. We could also see how big it was. So this is all the files. And then we do this file contents at 0 thing. For simplicity, let's just take this up to 100 out. In fact, let's just take all of that out. Shoot, what do we need that for? Let's take that out. Okay, now let's run this again. See what we get. What is file contents? Boy, that's looking like all the files that we read. And it's length 20, meaning that each file content, so each of the different texts are a different element of the list. Wow, that's wonderful. You can see that here if you look at the full content. So you can see this comma. So this is the 0th element, first, second, third, fourth, fifth. Oh, so now we have that as a list. We're liking list comprehensions. All right, so then again, if we, I think it is, but I'm not sure. You might want to check that yourself. Okay, so now let's look at one of the elements. So if we want to look at the 0th one, we can see that full set. Sometimes when you're working with Jupyter notebooks, you don't want to just like print something the full amount like this because it all shows up in the notebook like huge and you're scrolling for the rest of your life just to get to the next statement. So sometimes what I do just to get a little preview of what's going on is I do something like that. And I just get the first 100 like characters. So this is the 0th, oh, sorry. This is going to be the 0th element of file contents. This is going to be kind of like a slicer. It's saying, hey, just return me the first 100 characters with there being an implicit statement that this is 0. So this is from character 0 all the way up to character, or element all the way up to, not including 100. All right, so there we go. We'll just take a look at that. All right. Man, we're making progress. So now we have a list of the files. We have a list of the file contents. The last thing that we're missing, though, is the actual CSV file with all of our information. Okay, so how can we do that? Well, we'll do pretty much exactly what we did before. We have this file base, and all we need to do is just tack on that last little bit with the CSV. And so we can do that here. So we'll make a value or a variable called author path. We'll do just what we did before, file base. We're just going to tack on author data.csv. We can take a look at that. Author path, looking good. So this is what we want to read from. So here we're actually going to use a tabular data package, so Pandas. And so this is what we tend to do data analysis with because it's so great for working with tabular data. And if you looked into the other notebooks, there are a lot of different functions that one can use. And we're going to go briefly over some of the most powerful ones and maybe the most applicable ones to the situation that we're in. Okay, so we want to read this in as a data frame, because that's the structure for Pandas objects that have more than one column. And we're just going to do that. So we actually alias Pandas, so we didn't have to write the full Pandas. I'm just going to write PD. What is PD again? Just to show you so you know, we alias this, import Pandas as PD. So now we don't have to write Pandas, just in case it's pretty long. If you have to type it a bunch, it's irritating. Okay, so now we're at PD, and now we're going to use the read CSV function, because what we have is a CSV. And again, take a look at the arguments that are possible, the different variations that you can do on reading in a CSV file. And so there are lots of things that are already kind of defined for you, but you can change them. So these are all defaults that have these equal signs. The thing that doesn't have the equal signs is this file path or buffer. And it's saying, look, hey, what are you trying to get me to read? So we're going to tell it. And what is that? Author path. And then if we just want to take a look at the very beginning, actually, we'll just look at the limit, okay? So that will show us the rest of it. All right, so we're going to read that in. Great, wonderful, beautiful. We can see this is actually our data frame that we had. We have all the headings here. So last name, first name, age, years of journalism. Look at this one. This has a space instead of an underscore. This will come up later. And then this also, we also have the rest of the columns. So again, I think Jupyter Notebooks do a really great job of shortening this, but it depends where, like what is hosting it a little bit. And sometimes it will show you like a full data frame. So if you have thousands of rows, you'll again be scrolling for the rest of your life trying to find the next statement. Sometimes it's nice just to get a good intuition on what the beginning and the end looks like. So if you want to take a look at the beginning, you can use head. And that'll print the first in. And if you want it to be a different number that you print, you can just put a different number in there. So now we have the first in. We can also do the same thing with tail, and it'll show you the last of that. So actually that's good. And you can see here, these are named indices. So you can see the last thing. All right, moving right along. So now we have author data. We have all the contents of things. Okay, now we need to start to actually do our work. Before there, we might want to do just a little bit of EDA, just so we can understand a little bit about what's going on in our data, just have some sort of sense of things. Because right now, all we can do is see this. But if your data set was huge, you might not be able to look at every single little thing. Okay, so let's see. These are just some things that you might want to know. So how many rows and columns are there in the data? Okay. So specifically about this author DF, the way that you can find that out is to understand the shape of the data, right? Wonder if we can do anything with that. Just understand the shape. I just type in shape. Oh, it looks like that's a real thing. Note that it's a property, meaning that you don't call it with parentheses, but it's not a function. Okay, So let's take a look at that. Oh, interesting. It tells us 20 and 6. So 20 is the number of rows, as you saw before, and 6 is the number of columns. Now, here you see something that we didn't really talk about in depth. You can see this is a parentheses and another parentheses. This is a particular type of data structure, which is a tuple. So someone named that earlier, very similar to lists. It's just that they are immutable instead of being mutable. Okay. All right, so now we've got the shape. If you're thinking about this being a list, okay, think about it being a list. How could I get the number of rows back? So how could I get this specific value back? What would we do if this was a list, if we wanted to get this element? Okay, so that's what we would do if we wanted to get the length of it. Okay, we could index into it. Okay, so let's see what happens if we try to get the rows back using this zeroth index. So let's see. Let's just see how that goes. Oh my goodness, perfect. So you can index it very similar to a list. And if you want the column specifically, you can get it like so. Otherwise, it's going to tell you both. And so that is very similar to lists. So now we know a lot about tuples, just having known a lot about lists. All right, so let's see, how many null values does the data have? So this is another situation. Okay, so someone just said something really cool about this particular point. How many rows are there? They just said use len. You can most certainly do that. Great idea. For the number of columns, you can also just get the columns and count them. But this also gives you both at the same time. So that was a good idea for the person who wrote that, or the people who wrote that. All right. So understanding the null values, this is another situation where there are like a bazillion ways to understand how many null values are in your data set. But I'm going to tell you about one that I love in particular. So we're going to type in author df because that's the data frame that we want to know about. And then we're going to use the info method. What is that? It's a method. Okay. So we're going to run this. Let's see what it tells us. So the reason I like this is because it tells you a lot in one place, right? So first it tells you the class of what you're looking at. So this thing is a data frame. It tells you what the indices are, that it's a range index, meaning that it's just counted iteratively. If you read in the last notebook about range, this should make sense to you. But then it also tells you all about the data that you have. So it lists all the columns that you have with their names, okay, where it is. So it's integer location, right? The index in the data frame. And then it tells you how many are non-null, right? So if there were null ones here, this would not be 20. It would be something less. And this here and this would no longer match, right? So this is something that you can look at to see how many things are null in that particular column. And I really like that a lot. Lastly, what you can see is the type of that particular column. So these are going to be strings. Objects are things that are just like not like numeric or don't have like a specific kind of data type defined by Pandas. And then we have some integers as well. So those can be really nice. It also tells you about the memory usage, which can also be nice. So this is telling us about how many null values that the data has in each column. So that is something that we don't know. Okay, something else that we might be interested in. Oh, why 64? So these are 64-bit integers. There are shorter representations of integers as well, but these in particular are 64-bit, and it read these by default. If you want to change these when you read it, you can also do that using some of the arguments in read CSV. Okay, are all of the article IDs unique? So in your data set, you might have like unique authors, and so their IDs might need to be unique. But since multiple people in our data set can't write the same article, we're going to assume that all of these IDs should be unique as well. How can we do that? Well, there are many ways. So the way that I tend to go to first is I just look at the particular column. Okay, so keep in mind, when you think about data frames, you should be thinking about something that is a list and a dictionary together. So it's like very similar to someone asked a question about a name list. This is closer to like a name list where the names can be like the rows or the columns. So multiple lists. So very close to a table, but maybe not quite. So maybe don't put that in your mind. But you can think about them in terms of indexing similarly to dictionaries and lists. So let's see if we wanted to specifically get the a column in particular. So if we wanted to select a column, what we can do is just select like we normally do using our angle brackets, our square brackets. And then we tell it what column it is that we want to select. So Google Colab is so nice because it tells us some things that we can select. So let's choose article ID because we're trying to figure out if the article IDs are unique. So let's just take a look at what this outputs. Exactly what we thought. It picked this particular column, which is the article IDs. Something nice is that it prints the name of it. And also this is a Pandas series. So whenever you have a single column of a data frame, its default data type is going to be a series, meaning that you can still apply a lot of different functions to it that you can apply to data frames. So read in 2 and 3 notebooks, and they kind of go into detail about that. Okay, but now let's talk about which ones are unique. So you can call unique. Okay, let's see how that goes. Oh, so it tells us all of the unique ones. So it says that they are unique. So it tells you the unique ones, but how many is that? So of course you could use len. You could say len of this. And it would tell you 20, which is going to be the same exact size of this data frame. Okay, so that is very, very helpful. There are also other ways, and I'm just going to introduce you to this other way because if you're trying to compare uniqueness across a number of different columns, so maybe like some of them need to be unique and then other ones maybe don't, you can also use duplicated. And that tells you whether a column was or a row was duplicated or not. Here you go. So this says whether each one is a duplicate. No, it's not. So if it was the case that this one was a duplicate, this one would of 0, this one would say false, but this one would say true. So you could snatch it out. You can think about it like that. You can think about it like that conceptually. But just remember that is an underscore. All right, and so just remember when you have true and false, they are easily convertible to integers. So we can also do a sum here. Okay, so we're going to sum up all the false. Falses are pretty much 0. So sum of 0, 0. So we would want to see a 0 here. So this tells us that they are all unique because there are none that are duplicated. All right, so if there was one that was duplicated, if there were 5 that were duplicated, this would give you back a 5 and it would tell you how many are duplicated. So, okay. Let's see, what are the unique college majors and how many are there? So again, there are many ways to answer this. We just talked about using unique. So so just following up on using unique, how would I figure out what the unique college majors are? So based on what we just talked about. So author DF and then what? Blessed. Good job. So college major. So author DF, selecting the column college major and unique. Excellent, excellent, excellent. So this is precisely how we can do that. There are other ways to get information similar to this. So this says how many are there. So this was a very unfortunate way that this was phrased. It might be more interesting to know how many of each type of these majors are represented by the data set. And the way that you can do that is by getting the counts of each of these individual values. Okay, so these are the values, and we want to count how many times that they occur in the data set in that column. Well, we want to get, we have values, we want to get the counts. I wonder if that could be helpful. Oh my goodness, bless it. So It does give us exactly what we were looking for. So there are 6 humanities majors, 5 science, and so forth. And you can check this by counting yourself. Sometimes I do that if the data set is small enough. But something else really nice about this, and especially with Pandas, is you can just easily make this into a plot by plot. And you can tell it what kind you want. So what kind of plot do you want? Kind. Maybe we want a bar plot. So good. So good. So this will give you some visual EDA on things that you want to look at. Keep in mind that this returns a series, so we're calling this plot on a series object. And we will get more into these object-oriented concepts tomorrow. So now that we have some insight into our actual data, okay, let's talk about, okay, so I see we have a little bit less than 15 minutes. Let's talk about getting back to our original problem, given the things that, and the tools and what we've already loaded here, okay? So again, what we're trying to do, maybe, is we only want to use information from experienced journalists. So it's kind of an unfortunate phrasing on that, but we're going to define experience as people as having more than 5 years of experience. So we do have that column as years of journalism, right? Okay. So we have this data frame with the years of journalism with the IDs in it. And then we have a different list of IDs. And then we even have yet a different list of the actual text files. So now what happens when we only want to select the text which corresponds to the authors with more than 5 years of experience. So this is a bunch of different data structures that we now have to kind of juggle, right, to get the correct text which corresponds to these particular authors. Okay. Might take a little moment to thought there. Okay. So because it takes a moment of thought, we're going to have a little breakout discussion. You guys are going to go into rooms and try to think of the steps that you would take to try to put together all those pieces to get the text corresponding to authors with more than 5 years of experience, given the data frame that you have, the list of integer text IDs, the list of file names, and the actual list of text. And something to remember, though, that may make your work a little bit easier is that the indices across all of your lists match. Now, whether they match the data frame, I mean, that could be ambiguous. But all of the ones that you loaded as lists, all the indices will match, meaning that a particular file name corresponds to a particular file ID in that list, which corresponds to the text in another list, okay? So that's a lot of things to juggle. And don't worry about writing a single line of code here. Don't write it. Just write some pseudocode. Or just write the steps in regular narrative form. So think about what you would do to try to get the text corresponding to authors with 5 years of journalistic experience. And make sure to put that into your breakout rooms document.
And how long for the breakout room?
Let's see, what time is it? Maybe 7 minutes.
7 minutes, okay.
We'll come back and then discuss a little bit and prepare.
Okay. I'm opening them up now. Hey there, Mickey. Do you need to be sent into room 1?
I think I got it. I'll join.
Okay, great. All right. No. Oh, it looks like